Stand in the shadow of the Great Pyramid of Giza. Feel the sheer scale of it, the immense weight of millions of stone blocks rising into the sky. Now, try to erase from your mind everything you know about how such a thing is possible. Forget steel beams and computer-aided designs. Forget diesel-powered cranes and hydraulic lifts. Imagine the landscape around you empty, silent, populated only by people with stone tools, ropes made from plant fibers, and an idea so audacious it seems to border on madness. This is the world of the vanished architects, the master builders of forgotten civilizations whose achievements are so profound they continue to whisper a tantalizing question across thousands of years. How did they do it? These are not just old buildings, they are enigmas carved in granite and limestone. They are structures assembled with a precision that still baffles modern engineers, aligned to the stars with an accuracy we would struggle to achieve without satellites, and built to endure millennia of earthquakes and erosion. The true mystery lies not in the stones themselves, but in the stunning absence of the technology we assume is necessary to work with them. We are going on a journey to uncover the secrets of these forgotten civilizations that built without modern tools or metals, exploring the incredible architectural miracles they left behind. This is a story that stretches from the oldest known temple on Earth to a city built on a coral reef, from the misty plains of England to the high Andes Mountains. It is a global puzzle, and each site is a crucial piece. This video is an invitation to look closer, to question the very timeline of human progress we take for granted. We have been taught that advancement is a straight line, leading inevitably to our current technological sophistication. But what if that story is incomplete? What if these ancient cultures possessed a different kind of knowledge, a deep, intuitive understanding of physics, geology, and community that allowed them to achieve the impossible with nothing but sheer human will and ingenuity? Prepare to set aside everything you thought you knew, because we are about to delve into the methods and the minds of the world's most enigmatic builders. Their legacy is a challenge etched in stone, a silent testament to a power we are only just beginning to comprehend. Picture a modern construction site for a moment. The air hums with the sound of diesel engines, the sharp whine of diamond-tipped saws cutting through concrete, and the powerful groan of cranes lifting steel I-beams stories into the air. The workers, skilled as they are, rely on a symphony of technology that amplifies their strength 1,000-fold. Now, let that image dissolve and travel back in time. Replace the cacophony with the rhythmic, patient tap-tapping of a stone hammer. See an ancient Egyptian artisan, sweat glistening on his skin, patiently pounding a block of granite, one of the hardest stones on Earth, using nothing but a rounded ball of dolerite, a stone even harder than granite. There are no power tools, no metal chisels strong enough for the task, no detailed blueprints on a computer screen. There is only human determination, a profound understanding of the material, and time, generations of it. This stark contrast lies at the very heart of the mystery we are about to explore. What does it truly mean to build the impossible with what we would consider almost nothing? The architectural marvels we are investigating are defined by three astonishing characteristics. First is their megalithic scale. We are not talking about simple huts or stone walls. These are structures composed of colossal stones, each weighing tens or even hundreds of tons, moved over staggering distances and lifted to breathtaking heights. Second is their impossible precision. We see stone blocks carved and fitted together with seams so tight that, even after thousands of years, you cannot slide a piece of paper between them. We find foundations leveled to within a fraction of an inch over acres of land, and alignments with celestial bodies achieved with an accuracy that would challenge modern surveyors. The third, and perhaps most defining characteristic, is the complete absence of the metallurgical technology we associate with such feats. While some cultures later developed soft copper or bronze tools, these were often useless against the hard granite and basalt they chose to build with. The real tools were far more fundamental: intellect, physics, and an immense coordinated human effort. The genius of these builders was not in possessing secret technology, but in their masterful application of universal physical principles. They understood leverage intimately: how a long, sturdy wooden pole and a fulcrum could allow a small team to lift a weight that would otherwise require hundreds. They mastered the control of friction using log rollers, lubricated mud slipways, and perhaps even ice to slide massive stones across the landscape. They comprehended mass and inertia, knowing how to rock a multi-ton obelisk into an upright position using ropes and gradual, controlled force rather than brute strength. Modern physics can easily explain these principles on a blackboard, but what is staggering is the scale and confidence with which these ancient cultures applied them. We struggle to replicate their achievements even with our advanced knowledge, not because we don't understand the theory, but because we lack their sheer patience and the social structure to mobilize a workforce for a project that would not see completion within a single lifetime. Consider the sheer audacity of the project brief, if you will. It wasn't just to build a big tomb, it was to construct a mountain of stone that would point directly to the stars, with its sides aligned perfectly to the 4 cardinal directions, and to make it so enduring that it would stand until the end of time. This required more than just stonemasons. It required astronomers, surveyors, and logisticians who could plan for centuries. The same is true for temples built in active earthquake zones, designed with such flexibility that they dance with the tremors rather than shatter. This points to a deep, empirical knowledge gained through centuries of observation and experimentation, knowledge passed down through oral traditions and guilds of master builders. The question is not what advanced tool did they lose, but rather, what advanced mindset have we forgotten? Their philosophy of construction was one of harmony with the landscape, with the cosmos, and with the very properties of the materials they used. They did not seek to conquer nature with technology, but to collaborate with it, and in doing so, they created works that have humbled nature itself for millennia. This way of thinking, this deep integration of knowledge, is the core enigma we must unravel. To truly grasp the significance of what we are about to discover, we must journey to a barren, windswept hilltop in southeastern Turkey. Here, standing against the sky, are the silent, haunting remnants of Göbekli Tepe. This is not a city nor a fortress, but something far more mysterious. A series of circular enclosures built from massive, T-shaped limestone pillars. Each pillar is a monolith, some towering nearly 20 feet high and weighing many tons. But it is the intricate carvings that truly capture the imagination. A menagerie of foxes, scorpions, vultures, and boars, all etched with a skill and artistry that seems to belong to a much later age. The sheer scale is staggering, but the date is what shatters our understanding of history. This complex was constructed around 11,500 years ago. That is 6,000 years before Stonehenge, and a full 7 millennia before the Great Pyramid of Giza was even a concept. At this point in time, according to every history book written just a few decades ago, humanity was supposed to be composed of small, nomadic bands of hunter-gatherers, focused solely on survival, with no capacity for large-scale, coordinated construction. Göbekli Tepe proves that narrative is fundamentally wrong. The enigma begins with the most basic question: how How did a society that had not yet discovered metal tools, that did not even have the wheel or domesticated animals for heavy labor, accomplish such a feat? The limestone for these pillars was quarried from local bedrock. Archaeologists believe the builders used a technology of patience and percussion. They would have pounded the stone with rounded hammers made of dolerite, a harder rock, creating deep channels around the desired block. Wooden wedges, perhaps soaked with water to make them expand, could have been driven into natural fissures to help fracture the stone from the earth. Once a multi-ton pillar was freed, the real challenge began, moving it several hundred yards to the hilltop. Without wheels or beasts of burden, the only engine available was human muscle. The most plausible theory involves a combination of log rollers, ropes made from plant fibers, and teams of people pulling in unison. They might have created lubricated pathways of mud or clay to reduce friction, inching each colossal stone into position through a monumental effort of coordinated will. But the physical how is only half the story. The deeper, more profound mystery is why. What compelled these hunter-gatherers to undertake such a Herculean task? The site shows no evidence of permanent settlement, no houses, no granaries, no kitchens for feeding a large resident population. This was not a place for living, it was a place for gathering. The elaborate carvings of predators and prey suggest a rich, symbolic world, a complex mythology shared by different bands of people across a wide region. This points to a powerful, unifying belief system, a sacred purpose so compelling that it motivated hundreds of people to come together season after season, generation after generation, to build something grander than themselves. The construction of Göbekli Tepe was an act of collective faith. It was the belief system itself that likely provided the social glue, the organization, and the sustained motivation required for a project that spanned centuries. This revelation turns the traditional story of human civilization on its head. For generations, we have been taught a simple progression. First, humans discovered agriculture, which led to food surpluses. These surpluses allowed people to settle down in permanent villages, which in turn led to specialization: potters, weavers, priests, and eventually architects. Only then, with this settled, complex society, could humanity embark on massive building projects. Göbekli Tepe suggests the sequence may have been reversed. It implies that the human drive to come together for a shared spiritual purpose, to build a monumental temple, may have been the catalyst that forced us to organize. The need to feed the large groups of workers gathered at the site could have provided the incentive to experiment with cultivating wild grasses, potentially igniting the agricultural revolution. In this light, civilization may not have been born out of mere practicality, but from a deep-seated need to connect with something greater, to create a permanent mark on the world that reflected a shared identity. Göbekli Tepe is not just a collection of old stones. It is the first clue, the foundational chapter in the story of the vanished architects, hinting that their knowledge was not just technical, but profoundly social and spiritual, rooted in a past far more ancient and sophisticated than we ever imagined. From the ancient hilltop of Göbekli Tepe, our journey now carries us across thousands of miles and thousands of years to the warm, turquoise waters of the Pacific Ocean. Here, off the coast of the island of Pohnpei, lies one of the most surreal and enigmatic sights on Earth, Nan Madol. Imagine a city that seems to float on the horizon, a labyrinth of nearly 100 artificial islands, each a platform of colossal, dark stone, crisscrossed by a network of silent, narrow canals. This is the Venice of the Pacific, a title that barely begins to capture its otherworldly presence. But unlike Venice, built with the benefit of medieval engineering, Nan Madol was constructed with what appears to be an impossible set of constraints. It was the work of the Sordilor dynasty, a powerful line of chiefs who ruled this remote archipelago, and they built their aquatic capital using only the most fundamental of materials, volcanic rock and human ingenuity. The sheer substance of Nan Madol is what defies belief. The islands are not made of simple rubble, but are meticulously built up from colossal, prismatic columns of basalt. These are not rough, unshaped boulders. The volcanic activity that formed the island created basalt that naturally cools into crystalline, geometric forms, often appearing as massive 5- or 6-sided logs. The builders of Nan Madol quarried these immense columns, some weighing as much as 50 tons, and then transported them across the sea to construct their city. They stacked them log cabin style, layer upon layer, to form towering walls and filled the interiors with coral rubble to create stable ground. The precision of the construction is staggering. The basalt logs are fitted together with such care that the walls have withstood centuries of tropical storms and typhoons. This was not a haphazard pile of rocks. It was engineered architecture on a grand scale, executed in one of the most challenging environments imaginable. So, how was this marine metropolis built? The local legends offer a magical explanation. They tell of two brother sorcerers, Olasipa and Olasopa, who arrived from a distant land. Using their powerful magic, they commanded the massive stones to fly through the air from the quarry to the building site, settling them gently into place. It's a captivating story, one that speaks to the profound awe the site inspired in later generations. But the archaeological reality, while lacking in sorcery, is no less impressive. The more grounded theory involves an incredible feat of logistics and an intimate understanding of the natural world. The primary basalt quarry was not on Pohnpei itself, but on a smaller, neighboring island. This meant that every single multi-ton stone had to be moved over water. Researchers believe the builders constructed enormous bamboo rafts, lashing the buoyant stalks together to create stable, floating platforms. They would then have used the power of the tides to their advantage, waiting for specific tidal flows that would help carry the heavily laden rafts on the journey to the construction site. The coordination required for this operation is almost unimaginable. We are talking about teams of workers, likely numbering in the hundreds, maneuvering these rafts through open ocean using paddles and a deep, generational knowledge of the local currents. They would have had to time their efforts perfectly with the tides, using the sea's own energy as their engine. Once the rafts reached the shallow waters of the coral reef, the even more delicate task of offloading and positioning the basalt logs would begin. This might have involved rolling them onto smaller sledges or using a system of levers and flotation devices to guide them into their precise positions. The entire process was a symphony of coordinated labor, a mastery of basic physics applied on a heroic scale. It was a form of engineering that was perfectly adapted to its environment, turning the ocean from a barrier into a highway. The logistical nightmare extends beyond mere transport. The very decision to build on a coral reef is a statement of supreme confidence. A reef is a dynamic, living structure, not a stable foundation. By constructing these artificial islands, the Sordilor dynasty was literally creating their own territory, separating the seat of their power from the common people on the main island. The canals functioned as defensive moats, controlling access and reinforcing social hierarchy. The effort required to source the stone, coordinate its maritime journey, and assemble it with such precision speaks to a society with unparalleled project management skills. This was a civilization that understood hydrodynamics, tidal patterns, and structural engineering long before those terms were ever coined. Nan Madol is more than a city. It is a monument to human adaptation, a testament to a people who looked at the vast, challenging Pacific Ocean and saw not an obstacle, but the very foundation of their power. In this aquatic metropolis, we find a unique and brilliant branch of architectural genius, one that flourished in splendid isolation, proving that the drive to build the impossible is a universal human impulse, capable of emerging in even the most remote corners of the globe. Now, let us cross the Channel and journey to the windswept Salisbury Plain in southern England, where another timeless enigma rises from the green earth. Here, the iconic stones of Stonehenge stand in their silent, broken circle, a monument that has captivated the human imagination for millennia. Picture this landscape 4,500 years ago, a vast, open grassland under a wide, dramatic sky. This is not the work of a single lifetime, but of generations. Over centuries, Neolithic people transformed this place, digging a circular ditch and bank, arranging massive bluestones from distant Wales, and finally, erecting the colossal sarsen stones that form the familiar trilithons, the two uprights with a lintel across the top. The sheer scale of the project is staggering, but the true mysteries of Stonehenge lie in two profound questions. How did they move these monstrous stones, and why did they place them with such celestial precision? The logistics of the sarsen stones alone are a monumental puzzle. These are the giant grey sandstones that form the outer circle and the central horseshoe. The largest of these weigh up to 30 tons each, and they were sourced from the Marlborough Downs, a distance of about 20 miles to the north. While 20 miles may not sound immense, imagine moving a weight equivalent to several large elephants across rolling countryside without the wheel, without paved roads, and without draft animals. The most widely accepted theory involves a technique that could be called stone rowing. It would have required an immense social effort. First, wooden sledges would have been constructed. The enormous stone would be levered onto this sledge using timber poles as levers. Then, teams of people would have hauled it forward, likely on a track of smoothed log rollers laid down in front of the sledge. As the sledge passed over the last roller, that roller would be picked up and carried to the front, creating a continuous, slow-moving pathway. It is a process of immense patience, requiring coordinated chanting or rhythm to keep the teams working in unison, inching the monolith perhaps only a few hundred feet per day. But the sarsens are only half the story. The smaller, distinctive bluestones present a mystery that is even more perplexing. These stones have a different geological signature. They come from the Preseli Hills in Western Wales, a staggering distance of over 150 miles. How did stones from a Welsh mountainside end up on an English plain? One theory suggests they were carried by glaciers during the last ice age, deposited much closer to Salisbury Plain by natural forces. However, no conclusive glacial evidence has been found in the immediate area, leading many archaeologists to favor the incredible idea that Neolithic people transported them. If so, the journey would have been epic. Part of it might have been achieved by combining river transport and overland hauling. The stones could have been moved on wooden rafts along the Welsh coast and up rivers, then transferred back to sledges for the final overland trek. The sheer motivation required to undertake such a task is almost beyond comprehension. It suggests that these particular stones held a powerful, perhaps sacred significance, making the arduous journey not just a logistical challenge but a pilgrimage. This leads us to the deeper why, the purpose that justified such an immense investment of time and labor. Stonehenge is not a random arrangement of rocks. It is a sophisticated astronomical observatory. Its primary axis is aligned to the midsummer sunrise and the midwinter sunset. If you stand in the center of the circle on the dawn of the summer solstice, you will see the sun rise directly over the heel stone, a solitary sarsen placed outside the main circle. This alignment is too precise to be coincidental. It means the builders possessed a deep, generational knowledge of the solar cycle. They understood the slowly changing positions of the sun throughout the year, and they encoded that knowledge permanently into the landscape. This was a society of stargazers whose priests or wise ones were not just spiritual leaders but keen scientists, meticulously recording the movements of the heavens. The architecture itself speaks to this cosmic connection. The great trilithons in the center are arranged in a horseshoe shape that opens toward the solstice sunrise. The outer circle of sarcens, once joined by lintels, would have created a continuous ring, perhaps symbolizing the eternal cycle of the year. Stonehenge was likely a place of immense ritual significance, where thousands of people would gather at these key astronomical moments to celebrate, to mourn, to trade, and to reaffirm their connection to the cosmos and to each other. The stones are a permanent record of a civilization's intellectual and spiritual relationship with the universe. They represent a belief system where the cycles of the sun were intimately tied to the cycles of life, death, and rebirth. In this way, Stonehenge is far more than a calendar. It is a cathedral built to the sky, a testament to the human desire to find order in the cosmos and to mark our place within it. A project so important that it compelled people for centuries to drag mountains across the land and raise them to the heavens. Leaving the misty plains of Stonehenge behind, we now ascend into the thin, crisp air of the Andes Mountains, to a fortress that seems to grow directly from the spine of the earth itself. Sacsayhuamán, a monumental complex overlooking the ancient Inca capital of Cusco, presents a different kind of mystery altogether. While the previous civilizations astound us with the scale of stones moved over great distances, the Inca achievement is one of almost supernatural intimacy with the stone itself. The defining feature here is not immense weight but impossible precision. The walls of Sacsayhuamán are composed of colossal limestone, andesite, and diorite blocks, some weighing over 100 tons. Yet it is not their mass that leaves visitors speechless. It is the way they are joined. Each irregular, polygonal block is shaped to fit its neighbors with such breathtaking accuracy that the seams between them are virtually invisible. For centuries, people have said you cannot slide a razor blade or even a piece of paper between these stones. This is dry stone walling perfected to an art form that defies logic, built without a single drop of mortar to hold it together. So, how was this three-dimensional stone jigsaw puzzle assembled? The Inca did not have iron tools, let alone precision lasers. Their method was one of relentless patience and a profound understanding of material science. The process likely began with a technique known as knapping. Stonemasons would have used hammerstones, rounded rocks made of a harder material like quartzite, to patiently peck away at the surface of a new block. They would strike it repeatedly, not with wild force but with controlled, precise blows, essentially abrading the stone away grain by grain. It was a subtractive art, a conversation between the mason and the granite. They might have used sand as an abrasive, rubbing stones together with quartz, sand, and water in between to slowly grind the surfaces to a perfect plane. This was not a quick process. Shaping a single block to fit its space could have taken months. The goal was not to create a standard rectangular block, but to craft a unique polygonal shape that would lock perfectly into the complex, interlocking web of the wall. This leads to an even more fascinating theory, the concept of sounding the stone. Imagine an Inca master mason, his hands resting on a rough-hewn block. He would tap it gently with a small hammerstone, listening intently to the subtle pitch and resonance of the sound. A clear, high-pitched ring might indicate a solid, dense section of rock. A duller, deeper thud could reveal a hidden internal fissure or a natural fracture line. By listening to the stone, the mason could understand its internal structure, its hidden weaknesses and strengths. This intimate knowledge would guide his work, allowing him to shape the block in a way that followed its natural grain, much like a master woodworker carves with the grain of the wood. This was not brute force, it was a form of stone whispering, a tactile, sensory dialogue with the material that modern diamond-tipped saws and jackhammers completely bypass. The Inca understood that stone was not an inert obstacle to be conquered, but a living partner in the creative process, with its own personality and characteristics that had to be respected. The genius of Sacsayhuamán extends beyond the microscopic precision of its joints to the macroscopic design of its walls. The famous zigzag pattern of the largest walls is not merely an aesthetic choice, it is a masterpiece of military engineering. From a defensive standpoint, this serrated shape is formidable. Attackers attempting to scale the walls would be exposed to enfilading fire from multiple angles, with no safe place to take cover. The overlapping angles created deadly crossfire zones, making a direct assault a suicidal endeavor. But the design also served a crucial structural purpose, especially in one of the most seismically active regions on the planet. A straight, rigid wall would be vulnerable to cracking and collapse during an earthquake. The interlocking, polygonal blocks of a zigzag wall, however, behaved differently. During a tremor, the stones can shift and settle minutely against one another, absorbing and dissipating the energy of the quake. The wall literally dances with the earthquake, swaying and settling without breaking apart. This is passive seismic engineering of the highest order, a design so resilient that the walls still stand proud centuries after Spanish conquistadors attempted to dismantle them. This holistic approach, where beauty, defense, and seismic resilience are woven into a single, coherent design, reveals the core of the Inca architectural philosophy. They did not see a division between the practical and the spiritual, or between engineering and art. The stone was sacred, a part of the living landscape they called Pachamama, or Mother Earth. To build with stone was to engage in a sacred act, to harmonize their creations with the powerful forces of the natural world. The fortress of Sacsayhuamán was more than a military stronghold. It was a symbolic representation of Inca power and their unshakable connection to the land. Each perfectly fitted stone was a testament to their belief in order, community, and the divine right of their empire. In the shadows of these walls, we find a civilization that achieved a near mystical union with their material, turning the very bones of the mountain into a testament to human ingenuity that continues to withstand the test of time and tectonics. After marveling at the impossible precision of Inca stonemasonry, it's tempting to search for a lost high-tech tool, something fantastical that explains everything. But the truth is far more remarkable because it is rooted in reality. To understand these builders, we must look not for what they lacked, but for what they masterfully utilized. It's time to open the toolbox of the ancients and examine the actual, sophisticated implements that turned mountain ranges into monuments. Forget lasers and anti-gravity devices. Their technology was one of patience, leverage, and an intimate dialogue with the materials of the earth. Picture a workshop at the base of an Egyptian quarry. The air is thick with dust and the sound of countless rhythmic taps. The primary tool for shaping hard stone like granite or basalt wasn't a metal chisel, it was a simple ball of dolerite. Dolerite is an igneous rock even harder than granite. Workers would swing these hammerstones, pounding the surface of a granite block repeatedly. They weren't cutting the stone, they were pulverizing it grain by grain, following a carefully marked line. It's a method that seems brutally slow to us, but it was incredibly effective. For finer work, especially in softer limestone, they might use chisels made from copper. But copper is a soft metal, dulling quickly against stone. So, the real cutting power often came from adding an abrasive. They would sprinkle quartz sand onto the cutting line and then drag a copper saw back and forth. The sand, harder than both the copper and the limestone, did the actual cutting, while the copper tool simply served as a carrier for the abrasive. This is essentially the same principle behind modern diamond-tipped saws, where diamonds act as the abrasive. They were, in effect, using a primitive but highly effective form of sandpaper and power saw, powered not by electricity, but by human perseverance. The process of extracting a massive block from the living bedrock was another exercise in clever physics. How do you split 100-ton stone from a cliff face without causing it to shatter? The answer lies in a simple combination of wood and water. Workers would carve a series of holes along a natural fracture line in the rock. Into these holes they would drive dry wooden wedges. Then they would pour water over the wedges. As the wood absorbed the water, it expanded with immense, irresistible force, slowly and steadily forcing the rock to fracture along the desired line. This technique allowed for remarkably clean breaks, freeing giant blocks ready for shaping. For smaller, more precise work, tools made from antler were invaluable. An antler pick is surprisingly durable and effective for pecking away at stone or carving detailed channels. These weren't crude, makeshift tools. They were the perfectly adapted instruments of a specialized trade, each one the product of generations of experimentation to find the most efficient way to work with a specific material in a specific environment. But the most powerful tools in their arsenal weren't the ones they held in their hands. They were the principles of physics they held in their minds. The lever is a perfect example. Archimedes would later famously speak of moving the world with a lever, but these builders had already mastered the concept. A long, sturdy wooden pole placed over a fulcrum, a smaller rock or a wooden block, could create a massive mechanical advantage. A small team of workers applying force to the long end of the lever could generate enough power to lift the corner of a multi-ton block. Once lifted, other workers could slide stone or wooden shims underneath, gradually raising the block inch by painstaking inch. This same principle applied to moving these colossal stones. Using a system of ropes and brute strength alone would be futile, but by placing a series of wooden rollers under a sledge carrying a stone, friction was dramatically reduced. Teams of pullers could then drag the sledge forward, with workers constantly moving the rollers from the back to the front in a continuous, slow-motion conveyor belt. The controlled use of friction was key. They would often pour water or a slick clay slurry on the path ahead of the sledge, turning it into a slippery slide that made the Herculean task merely immensely difficult. Perhaps the most awe-inspiring application of this simple physics was the positioning and erection of obelisks and standing stones. The process of raising a stone is a delicate ballet of controlled force. Imagine a multi-ton obelisk lying on the ground on an earthen ramp. Teams of workers with ropes would slowly pull the top of the stone upward, while another team at the base would use levers to control the pace and guide the stone's base into a prepared foundation hole. It wasn't a single, dramatic heave. It was a gradual, coordinated effort with the stone inching upward degree by degree, its weight carefully managed by the opposing forces of the ropes and levers until it slid perfectly into its vertical position. This required not just muscle, but an exquisite understanding of balance, pivot points, and mass distribution. A single misstep could mean catastrophe, shattering the stone and likely costing lives. The success of these operations speaks to a deep, practical knowledge of engineering principles that were only formally described by scientists thousands of years later. The real secret weapon, then, was not a mysterious artifact but a profound social and intellectual system. This was a technology of knowledge, meticulously accumulated and passed down through generations within guilds of master masons. A young apprentice would not just learn how to swing a hammerstone, he would learn the sound a granite block makes when it is solid versus when it has a hidden fissure. He would learn the exact angle to place a lever for maximum lift and how much water to use to lubricate a sled path for optimal glide. This was a living science refined through endless trial and error, tailored perfectly to the local geology and materials. What we might dismiss as primitive was in fact a highly evolved and specialized discipline. Their tools were not separate from their intellect, they were the physical extensions of it. The hammer was an extension of the arm, the lever an extension of the mind's understanding of physics. This synergy between human ingenuity and the fundamental laws of nature is what truly built the ancient world, proving that the most advanced technology is sometimes not complex machinery, but simple wisdom applied on a monumental scale. Archimedes may have given the lever its most famous quote, but he was simply putting into words a principle that stonemasons had been using for millennia. The ancient builders were masters of leverage long before it had a formal name. They understood on an intuitive and practical level that a long, sturdy pole wasn't just a tool for prying. It was a machine that could multiply human strength exponentially. The secret lies in the relationship between the force you apply, the length of the lever, and the position of the pivot point or fulcrum. Think of a simple seesaw. If a heavy adult wants to lift a light child, the adult sits much closer to the center. The child, sitting far out on the other end, can easily rise into the air. The lever trades distance for force. You push down a long distance on your end to lift the heavy object a short distance on the other, but with a fraction of the effort it would take to lift it directly. This concept, which we now call mechanical advantage, was the invisible engine behind some of the most back-breaking tasks. Imagine a multi-ton stone block that needs to be lifted just a few inches off the ground to allow workers to slide shims underneath. Trying to lift it directly with ropes and pure muscle would be futile, but with a team of levers, it becomes a manageable, step-by-step process. A worker would slide a strong wooden pole under the edge of the block, placing a smaller, harder rock directly beneath the pole as the fulcrum. Then he and others would throw their weight onto the long end of the lever. The force they exerted, amplified by the lever's length, would be concentrated on the short end under the stone, lifting that colossal weight with a controlled, grinding motion. Once the block was raised an inch or two, other workers would quickly jam stone chips or wooden blocks beneath it to hold it in place. Then the process would repeat, lever by lever, lift by lift, gradually raising the stone to the desired height. This was slow, meticulous work, but it was achievable. It turned an impossible feat of strength into a problem of patience and coordination. But the lever was just one tool in their kit of simple machines. Equally important was the inclined plane. Rather than lifting a stone vertically, which requires overcoming its entire weight at once, why not simply slide it up a gentle slope? The ramp is one of the most fundamental and brilliant applications of this idea. The Great Pyramids of Egypt almost certainly relied on massive earthen ramps, built from desert clay and rubble, spiraling around the rising structure. Pulling a stone on a sledge up a long, gradual ramp requires a constant, manageable force, spread out over the entire distance. The steeper the ramp, the more force required, so the builders used incredibly long inclines to make the task feasible for large teams of pullers. This is another trade-off. You travel a much longer distance, but you use far less force at any given moment. It's a perfect example of how these builders thought in terms of managing work over time, rather than seeking a single, instant solution. This leads us to the third critical element, managing friction. Sliding a multi-ton block, even on a ramp, would create immense grinding friction that could halt progress. Here, the ancients demonstrated their genius once more. They became adept at turning high-friction surfaces into low-friction pathways. The most common method was the use of log rollers. By placing a series of smooth, sturdy logs underneath a sledge, the sliding friction is replaced by the much lower rolling friction. As the sledge moves forward, rollers from the back are continuously carried to the front, creating a continuous track. To make this even more effective, they would lubricate the path. Evidence suggests they used water, or a mixture of water and clay, to create a slick, muddy surface that further reduced resistance. In colder climates, it's possible they even iced their pathways, creating a near-frictionless slide. This wasn't just about making the work easier, it was about making it possible at all. By intelligently reducing the forces working against them, they could direct all their human power into the task of movement. The true marvel, then, is not that they understood these principles in isolation, but the scale and consistency with which they combined them. A single project might involve using levers to load stones onto sledges, rollers and lubricants to transport them across miles of desert, and immense ramps to raise them hundreds of feet into the sky. This was applied physics on an epic scale. They were conducting a symphony of simple machines, each one playing its part in a process that could span decades. They didn't need Newton's laws of motion written down. They could feel them in the strain of the ropes and the groan of the wood. Their legacy is a masterclass in seeing the world not as a set of obstacles, but as a collection of opportunities. They looked at a long tree trunk and saw a force multiplier. They looked at a muddy slope and saw a highway for mountains. By harnessing the fundamental laws of the physical world with unwavering patience and brilliant organization, they turned simple principles into the very engines that built their empires, proving that the most powerful technology is often the simplest wisdom, applied with monumental determination. But the stones themselves could not move, and the levers did not pull their own weight. Behind every monolith, every perfectly fitted block, stood the most vital and complex component of the entire operation: people. We have explored the physics of leverage and the geology of quarries, but to truly solve the mystery of these constructions, we must shift our focus from the inanimate to the human, from the tools in their hands to the society that organized their hands. The real engine of these projects was not a mysterious technology, but a breathtakingly sophisticated social machine, capable of mobilizing and sustaining thousands of individuals for generations. So, who were these people? They were not a faceless, nameless horde of slaves, as depicted in old Hollywood epics. Archaeological evidence, particularly from the workers' villages at Giza, paints a very different picture. These were often skilled laborers, organized into crews with names like the Friends of Khufu or the Drunkards of Menkaura, teams who took pride in their work. They were farmers who came to work on the pyramid during the annual inundation of the Nile, when their fields were flooded and agricultural work was impossible. This was not the brutal, life-crushing slavery of later eras. It was often a form of rotational civic duty, a corvée labor system where citizens contributed a portion of their time to state projects. For the Inca, this system was known as mita, a mandatory public service where communities provided workers for state projects like building roads, temples, or terraces. In return, the state provided security, organized feasts during the work, and redistributed resources, creating a reciprocal relationship that strengthened the entire empire. The motivation that drove these vast workforces was a powerful fusion of the spiritual and the social. For the average Egyptian, working on the pharaoh's tomb was not just a job, It was a religious act, a direct participation in ensuring the cosmic order. The pharaoh was a god-king, and his successful journey to the afterlife was believed to guarantee the continued fertility of the Nile and the stability of the kingdom. By moving a single stone, an individual was contributing to the spiritual well-being of their entire civilization. This sense of shared purpose, of being part of something far grander than oneself, was a potent motivator. Similarly, at Göbekli Tepe, the hunter-gatherers who gathered to erect the massive T-shaped pillars were likely bound by a powerful, shared belief system. The act of building the temple was itself the ritual, a communal activity that reinforced social bonds and created a collective identity among otherwise scattered bands. The project was the purpose. The logistical challenges of managing such an endeavor are almost as impressive as the construction itself. Imagine the pyramid project as a massive, decades-long corporation. Feeding 10,000 workers required a constant, staggering supply chain. Vast bakeries and breweries were built near the site to produce bread and beer, the staples of the Egyptian diet. Herds of cattle were driven from across the country to provide meat. This required administrators to manage the grain harvests, scribes to record distributions, and guards to protect the supplies. Shelter had to be built and maintained. There were overseers, engineers, doctors, and cooks, an entire support city thriving at the foot of the rising monument. This level of organization speaks to a highly developed bureaucracy, a government capable of planning years, even decades in advance. It was a testament to the power of central authority, yes, but also to the cooperation of countless local communities who contributed their surplus and their labor to a national project. The construction site itself was far more than a workplace. It was a crucible where culture was forged. It was a place where a young farmer from a remote village could learn the skilled trade of stonemasonry. He would work alongside experienced artisans, acquiring knowledge that he could take back to his community. It was a place where people from different regions of a kingdom would meet, exchange ideas, share stories, and intermarry. The constant, shared effort of working toward a common goal, of solving immense practical problems together, created a powerful sense of shared identity and national unity. The monument they built was a physical symbol of that unity, but the process of building it, the daily cooperation, the shared struggles, the collective triumphs, was what truly welded a diverse population into a cohesive civilization. The finished pyramid or temple was the destination, but the journey of building it was what transformed the people themselves. This human network, with its complex web of beliefs, obligations, and logistics, was ultimately the most sophisticated tool the ancients ever devised. A lever can multiply force, but it takes a society to decide where to apply that force and to organize the people who will push it. The true marvel is not that they moved mountains of stone, but that they moved mountains of human potential. They harnessed the power of community, channeling it with such focus and patience that they could alter the very landscape. In the end, the greatest legacy of these vanished architects may not be the silent stones they left behind, but the profound lesson they offer about what human beings can achieve when they are united by a common vision and bound together by a shared sense of purpose. The social engine they built was, in many ways, their most enduring and impressive creation. Before a single stone could be lifted or fitted, the ancient builders faced their first and most fundamental challenge, finding the right stone and convincing the earth to give it up. This journey takes us from the finished monument back to its very origin, to the quarries where the raw material of history was wrested from the ground. It was here, in these vast, open-air workshops, that we see the first evidence of their genius, a profound, almost intuitive understanding of geology that transformed them into master detectives of the Earth's crust. Perhaps no single site offers a more dramatic snapshot of this process than the granite quarries of Aswan in southern Egypt. Here, still lying in its cradle of bedrock, is the unfinished obelisk. Had it been completed, it would have been the largest single piece of stone ever carved by the ancient Egyptians, towering over 130 feet and weighing an estimated 1,200 tons. Its abandonment, likely due to a catastrophic crack discovered during extraction, is our great fortune. It is a frozen moment in time, a three-dimensional blueprint revealing every step of the quarrying art. The entire surface of the surrounding trench and the obelisk itself is pockmarked with thousands of small, rounded depressions. These are the unmistakable tool marks of dolerite pounders. Teams of workers would have sat along the intended fracture line, rhythmically pounding the granite with these hard stone balls, not to cut it, but to pulverize it, creating a deep channel that would eventually isolate the obelisk from the living rock. The scale of the undertaking is humbling, a testament to an ambition that borders on the sublime. But why choose granite in the first place? It is one of the hardest stones on the planet, a brutal material to work with using Stone Age technology. The answer lies in the very properties that made it so difficult, its incredible durability and its striking visual presence. Granite, born from molten magma deep within the earth, is virtually impervious to erosion. The Egyptians knew that by using it for obelisks, sarcophagi, and the outer casings of pyramids, they were building for eternity. They were making a statement in stone about permanence and power. In contrast, the massive core blocks of the pyramids were often made of limestone, a softer, sedimentary rock that was far easier to quarry and shape. Limestone was the workhorse, chosen for its abundance and manageability, while granite was the prestige material, reserved for the most sacred and symbolic elements. Similarly, the builders of Nan Madol sought out basalt for its strength and its unique prismatic columnar structure, which essentially provided nature's own preformed building logs. This selection process reveals an encyclopedic knowledge of local geology. These builders were not randomly hacking at rock faces. They knew exactly what they were looking for. They understood that not all stone is created equal. They could identify the specific geological layers within a quarry that would split cleanly and yield the largest, most stable blocks. This knowledge was likely accumulated over centuries, passed down from master quarryman to apprentice. They learned to read the stone, to identify natural fault lines, fissures, and weaknesses that could be exploited. A skilled eye could spot a seam in the rock that promised a perfect fracture, saving months of backbreaking labor. To encourage that fracture, they employed a brilliantly simple technique that harnessed the power of physics, thermal shock. The process likely involved first building a large fire directly against the rock face along the desired fracture line. The intense heat would cause the outer layer of the stone to expand rapidly. Then, just as the rock was glowing hot, workers would douse it with cold water. The sudden, violent contraction created immense stress within the stone, causing it to crack along the weakened line. This cycle of fire and water could be repeated to deepen the fissure until a manageable block was freed. It was a method of controlled violence, using elemental forces to do the work that hammers alone could not. Once a block was isolated, the delicate task of undercutting it and moving it from the quarry began. This is where wooden levers, ropes, and a thorough understanding of leverage came into play. Workers would carefully tunnel beneath the block, inserting wooden beams as supports. Then, using levers on these beams, they would gradually rock the massive stone, slipping rollers underneath before inching it onto a sledge for its long journey. The quarry floor itself became a landscape of logistics, with pathways cleared and lubricated to facilitate the movement of these multi-ton prizes. The entire operation, from identifying the perfect seam of rock to loading a finished block for transport, was a symphony of geological insight and practical physics. It was a deep, symbiotic relationship with the earth, where the builders listened to the whispers of the stone and responded with a combination of brute force and exquisite finesse. The quarry was not just a source of materials, it was the first and most critical classroom where the ancient architects learned the language of the land, a dialogue that would ultimately allow them to write their ambitions across the sky. While the stones and the social organization are the physical heart of these structures, to truly understand their purpose we must look upward, to the skies that guided their creation. The precision with which these monuments align with celestial bodies is one of the most compelling threads connecting these disparate cultures. This field of study, known as archaeoastronomy, reveals that for the ancients, architecture was far more than shelter. It was a sacred language for conversing with the cosmos. The Great Pyramid of Giza offers perhaps the most famous example of this celestial choreography. Its four sides are aligned with the four cardinal directions north, south, east, and west, with an error of less than 1/15 of a single degree. This is not a rough approximation. It is a level of accuracy that would be challenging to achieve today without modern surveying equipment and GPS satellites. This alignment was intentional and profoundly significant, reflecting a belief that the pharaoh's journey to the afterlife was mirrored by the sun's daily journey across the sky, and that his tomb should be perfectly oriented within this cosmic framework. Across the sea, the builders of Stonehenge encoded a different but equally precise astronomical understanding. The primary axis of the stone circle is aligned to the point on the horizon where the sun rises on the summer solstice, the longest day of the year. If you stand in the center of the circle at dawn on that specific day, you would see the sun appear to rise directly over the outlying heel stone, casting its long rays into the heart of the monument. Conversely, the structure also marks the winter solstice sunset, the shortest day, framing it within the Great Trilithons. This turning of the year was not just a calendar event. It was a moment of deep spiritual power, a time when the veil between the human world and the divine was believed to be thinnest. The stone served as a permanent, unchanging guarantee that this celestial event would be witnessed and celebrated year after year, generation after generation, tying the rhythm of their society to the immutable cycles of the cosmos. The immediate question that arises is a practical one. How was this celestial precision achieved without any of the technology we take for granted? The answer lies not in complex machinery, but in the patient application of simple tools and generations of meticulous observation. In Egypt, astronomers' priests used an instrument called a merkit. This was a simple, forked stick with a plumb line hanging from it. By sighting the stars through the fork and aligning the plumb line, they could track the transit of specific stars across the night sky with remarkable accuracy. They likely used pairs of these instruments to create true north-south lines. One theory suggests they would mark the position of a star as it rose in the east and again as it set in the west. By bisecting the angle between these 2 points, they could find a true north-south axis. This process required nights, perhaps entire seasons, of patient stargazing, but the result was an orientation so perfect it has endured for millennia. For solar alignments like those at Stonehenge, the primary tool was even more fundamental: the gnomon, which is essentially a simple stake placed vertically in the ground. By carefully tracking the moving shadow cast by the gnomon throughout the day and across the seasons, an observer can map the sun's path. The shadow is longest at the winter solstice and shortest at the summer solstice. By marking the extreme points of the shadow's tip at sunrise and sunset over the course of a year, these ancient astronomers could pinpoint the solstices with great certainty. This knowledge was then translated into architecture by placing stones or digging post holes to permanently mark these celestial events on the landscape. This was a science built on patience, on the cumulative knowledge of elders passed down to apprentices, creating a living database of astronomical observation that was literally set in stone. This celestial connection elevates these structures from mere buildings to something far grander. They were, in effect, massive calendars and observatories. The pyramid complex at Giza, for example, has air shafts that some researchers believe were aligned with specific stars like Thuban, the pole star of that era, which was associated with the god Osiris. In Central America, the Pyramid of Chichen Itza is designed to create a shadow serpent that slithers down the staircase during the equinoxes. These were not random aesthetic choices. They were deliberate, functional designs that integrated celestial phenomena into the very fabric of daily and ceremonial life. The architecture became a dynamic participant in the cosmic dance, changing with the seasons and the years, reminding the people of their place within a vast, orderly universe. This was a profound dialogue between heaven and earth, where human ambition and celestial order met, resulting in monuments that were not just built for the sky, but were built from the sky, their blueprints written in the movements of the sun, moon, and stars. When we look at our own modern architecture, we see a world defined by the straight edge and the perfect 90-degree angle. It's the language of efficiency, of prefabrication, of mass production. But the Inca and other master stonemasons across the ancient world spoke a different, more complex dialect, one written in a jigsaw puzzle of irregular polygons. At first glance, the walls of Sacsayhuamán or the foundations of Machu Picchu appear chaotic, a random pile of bizarrely shaped rocks, but this impression is a profound illusion. What looks like chaos is, in fact, a masterpiece of controlled complexity. The question that naturally arises is why? Why would any builder choose such an incredibly labor-intensive method, painstakingly shaping each block into a unique, multifaceted form when stacking simple rectangles would seem so much faster? The answer lies not in an aesthetic whim, but in a deep, hard-won understanding of the Earth's violent power, an engineering solution born from necessity in one of the most seismically active regions on the planet. Imagine a standard wall built from uniform, rectangular blocks, neatly stacked and held together with mortar. Now, subject that wall to the violent, shaking force of a major earthquake. The rigid, brittle structure has no give. The mortar cracks, the straight lines become points of extreme stress, and the entire wall tends to fail by cracking along the joints and collapsing. It's a fundamental weakness of right angles under shear forces. Now, visualize the Inca polygonal wall. Each stone is an irregular shape with multiple contact points and interlocking edges. During a tremor, the energy from the quake travels through the wall, but instead of meeting a rigid, unyielding grid, it encounters a dynamic, multi-directional network. The stones lacking mortar are free to minutely shift, rotate, and settle against one another. They absorb the energy, dissipating it through countless tiny movements and friction points. The wall literally dances with the earthquake, swaying and settling, and when the shaking stops, the stones simply lock back into a new, stable configuration. It's not just a wall, it's a seismic shock absorber carved from solid rock. This genius for resilience reveals a level of empirical engineering that is simply staggering. The Inca did not have a formal science of structural dynamics or textbooks on plate tectonics. Their knowledge was written in the rubble of earlier, less sophisticated structures that had failed. They learned through centuries of observation and painful experience what worked and what did not. They understood that to build for eternity in the Andes, their structures had to be partners with the mountain, able to flex and move with it rather than resist it unto destruction. This polygonal technique represents a brilliant adaptation to their environment, a perfect fusion of form and function where the very irregularity of the design is the source of its ultimate strength. It is a lesson that modern engineers in earthquake zones are still relearning today, often turning to these ancient walls for inspiration in designing base isolators and flexible joints. Beyond the sheer physics, the creation of such a wall was an act of sublime artistry. Each block was a one-of-a-kind piece in a massive, three-dimensional stone puzzle. The master mason had to possess an almost sculptural vision. He would select a raw stone from the quarry and begin the slow, patient process of knapping it with a harder hammerstone, pecking away at its surface. But he wasn't just shaping a block to fit a predetermined space. He was engaged in a continuous dialogue with the wall itself and the stones already in place. He would have to constantly test the fit, looking for the subtle concavity on one stone that could accept the convexity of another. The goal was to maximize the contact points between stones, creating an immense surface area of friction that would lock them together. This required an intuitive grasp of geometry and spatial relationships that far surpasses the simple need for a level surface. The process was one of incredible patience and skill. There were no blueprints with precise angles and measurements for each stone. Instead, the wall grew organically, with each new block being custom shaped to fit the evolving pattern. It's akin to the work of a dry stone waller, but on a colossal architectural scale. The masons likely used a system of strings and plumb bobs to maintain the overall level and batter of the wall, but the intricate fitting was a tactile, visual art. They would have used abrasive sand rubbed between the stones to gradually grind the surfaces to a perfect, seamless fit. The result is a testament to a culture that valued quality and permanence above speed and ease. The extra effort invested in the polygonal technique was not wasted time. It was an investment in survival, a guarantee that their work would endure the test of both time and tectonics, standing as a silent tribute to a civilization that truly knew how to listen to the stone and build in harmony with the powerful forces of the earth. While we have marveled at the use of levers and stone hammers, there is another, more fluid element that these ancient builders mastered with equal brilliance: water. Far beyond a simple necessity for life, water was in many ways one of their most versatile and powerful construction tools. Imagine the challenge of leveling the 13-acre foundation of the Great Pyramid to a near-perfect plane, with deviations of less than an inch across its entire vast surface. How could such precision be achieved over such a distance without modern laser levels? A compelling theory points to the simplest of solutions: a network of shallow trenches dug into the bedrock plateau. The builders would have flooded these trenches with water, creating a series of interconnected pools. Since water always finds its own level, the surface of the water in each trench would present a perfectly horizontal plane. By measuring down from this consistent waterline to the bedrock at countless points across the site, workers could systematically chip away the high spots until the entire foundation was uniformly level. This was not just a clever trick, it was an application of a fundamental law of physics, using the behavior of water itself as a giant, self-correcting measuring instrument. This same principle of water finding its level was likely instrumental in the creation of the vast, intricate canal systems that served as the lifeblood of Mesopotamian cities. While these canals are celebrated for irrigation, their role in construction logistics is often overlooked. Transporting heavy materials like timber, stone, and clay bricks overland was slow and grueling. But by integrating their building projects with the waterways, Mesopotamian engineers could move massive quantities of supplies with remarkable efficiency. A heavy stone block that would require hundreds of laborers to drag across the desert could be floated on a barge along a canal with a fraction of the effort, pulled by a small team or even carried by the current. This hydraulic network transformed the landscape, turning stubborn distances into easily navigable highways. It was an early form of industrial logistics, where the control of water meant the control of movement, enabling the construction of the great ziggurats and city walls that defined their civilization. The power of water to reduce friction was another tool in their arsenal, one that might hold the key to one of archaeology's most captivating puzzles, the movement of the Moai on Easter Island. The dominant theory, popularized by experimental archaeology, suggests the massive statues were walked upright to their ceremonial platforms. Teams of rope pullers would have rocked the Moai from side to side, inching it forward in a controlled, swaying gait. Now imagine this process on the rough, volcanic terrain of the island. The constant friction between the stone base of the statue and the ground would have made progress agonizingly slow and risked damaging the delicate carving. This is where water and mud come into play. By lubricating the path ahead of the Moai with a slick slurry of water and soil, the pullers could dramatically reduce the grinding resistance. The statue would be able to pivot and tilt more easily, its base almost hydroplaning across the temporary, muddy surface. This simple act of turning the path into a slipway would have made the seemingly impossible task of moving multi-ton statues across miles of countryside a manageable, albeit still monumental, endeavor. Even in the very act of extracting stone from the earth, water proved essential. We've already discussed the use of fire and water to create thermal shocks in quarries, but water's role was sometimes even more direct. In some softer stone like limestone or sandstone, workers could use water-saturated wooden wedges. By driving dry wedges into cracks in the rock and then soaking them, the expanding wood would exert a steady, immense pressure, cleanly splitting the stone along desired lines. This controlled use of hydraulic force allowed for precise quarrying without the risk of shattering the valuable block. Furthermore, the constant need for water at the quarry site for drinking, for mixing mud lubricants for sledges, and for the workers themselves necessitated sophisticated water management, from digging wells to creating small reservoirs, showcasing a holistic understanding of resource allocation. This mastery over water reveals a pattern of fluid intelligence, a way of thinking that sought to collaborate with natural forces rather than simply overcome them through brute strength. The relationship was also deeply symbolic. In Egypt, the annual flooding of the Nile was not just a practical benefit for agriculture, it was a divine event, the god happy bringing life and fertility. By using water to build the pharaoh's eternal tomb, they may have been infusing the structure with this life-giving, sacred power. Water was a practical tool, but it was also a spiritual element, and its use in construction bridged the gap between the earthly and the divine. The ancient builders saw in a simple pool of water a universal level, in a muddy patch of ground a frictionless highway, and in a rushing stream a source of power. Their genius lay in perceiving these potentials and harnessing them on a scale that still inspires awe, demonstrating that sometimes the most advanced technology is not a complex machine, but a profound understanding of the elements that have always surrounded us. To truly understand why these civilizations invested centuries of labor into moving mountains of stone, we must learn to read their language. But this was not a language written on papyrus or clay tablets. It was a vocabulary carved into the very landscape, a grammar of form, scale, and alignment that spoke directly to their deepest beliefs about the universe. The stones themselves were the words, and the monuments were complete sentences declaring their place in the cosmos. The Pyramid of Giza is the most iconic example. Its smooth, gleaming sides, originally covered in white Chora limestone, would have reflected the sun like a beacon, but the shape itself is the message. The pyramid is a ramp, a staircase pointing directly from the earth to the realm of the stars. For the ancient Egyptians, the deceased pharaoh was not dead. He was ascending to join the sun god Ra in his eternal journey across the sky. The pyramid was his launch pad, a machine designed to facilitate this divine transition. Its perfect orientation to the cardinal directions anchored it within the cosmic order, while its immense, unchanging mass was a promise of eternal life, a defiance of decay that echoed their belief in the soul's immortality. This symbolic language shifts dramatically when we enter the dark, confined space of a Neolithic burial mound, like Newgrange in Ireland. Here, the architecture is not about ascension but about descent and rebirth. The experience is intentionally inward and downward. A long, narrow passageway, so low that you must crouch, leads deep into the heart of the earth. This labyrinthine corridor is a physical representation of the journey to the underworld, a symbolic death before reaching the central chamber. But at the end of this tunnel lies a miracle of archaeoastronomy. Above the entrance, a small, perfectly aligned opening known as a roof box was designed so that on the dawn of the winter solstice, the shortest day of the year, a single, sharp beam of sunlight would pierce the darkness and illuminate the inner chamber for just 17 minutes. In that moment, the architecture transforms. The tomb becomes a womb. The sun's light penetrating the earth symbolizes the fertilization of the land, the promise of the sun's return, and the hope for rebirth after death. The entire structure is a calendar, a clock, and a profound spiritual statement about the cyclical nature of existence. Even the choice of material and the sheer scale of the stones carried a potent message. Why use a 200-ton block when a dozen smaller ones would create a perfectly stable wall? The answer lies in the psychology of power and permanence. A wall made of cyclopean stones, like those at Sacsayhuamán or Mycenae, communicates an unshakable message of authority. It tells the observer that the builders commanded such immense resources and such control over their people that they could accomplish the seemingly impossible. The effort required to move and position such a block is so far beyond everyday experience that it transcends the practical and enters the realm of the mythic. The stone itself becomes a symbol of the state's invincibility and its claim to eternity. The irregular, polygonal joints that make the wall earthquake-proof also make it impossible to disassemble. It is a permanent, unified whole, just like the empire it represents. The stone's resistance to time is a metaphor for the dynasty's desire for everlasting rule. Now, let's return to the very beginning of our story, to the mysterious T-shaped pillars of Göbekli Tepe. The sophisticated carvings of animals, vultures, scorpions, foxes, and boars are not mere decoration. They are a complex symbolic code that we are only beginning to decipher. One compelling theory suggests these animals are not just a random menagerie but represent specific constellations. The vulture, for instance, holds a prominent place in later Near Eastern mythology and may have corresponded to stars we know today. If true, the stone circles of Göbekli Tepe would be more than a temple. They would be a three-dimensional star map, an epic of creation frozen in limestone, telling a story about the gods and the origins of the world. The pillars themselves, with their abstracted human forms, arms, hands, and loincloths carved onto the stone, may represent ancestral spirits or powerful deities, their gaze fixed eternally on the celestial drama above. The act of building this complex was therefore an act of storytelling, of literally constructing their mythology into the landscape for all to see and participate in. Ultimately, this symbolic dimension is the key that unlocks the mystery of their motivation. The immense effort, the generations of toil, the staggering logistical challenges, all of it was justified by a worldview that saw no separation between the physical and the spiritual. For these cultures, a mountain was not just a geological feature, it was a sacred being, the abode of a god. A river was not just water, it was a life-giving deity. By building a pyramid that mirrored the sacred Benben stone of creation, or a temple aligned with the solstice sun, they were participating in the maintenance of cosmic order. They believed that their rituals, enacted within these architecturally perfect settings, were essential to ensuring the sun would rise, the Nile would flood, and life would continue. The architecture was the stage for this sacred drama. It was a contract with the gods, written in a language of stone that they believed would last forever. To build was to pray, to create was to worship, and the resulting monument was a permanent prayer, a desperate and beautiful attempt to etch their beliefs into the very bones of the earth, ensuring their message would be read by the heavens for all eternity. Now let's travel to one of the most isolated places on Earth, a tiny volcanic speck in the vast expanse of the Pacific Ocean. Here on Easter Island, or Rapa Nui, we encounter a mystery that has become a global icon, the Moai. Picture the landscape, rolling green hills dotted with hundreds of these colossal stone figures, their stern, elongated faces staring silently inland. Some stand proudly on massive stone platforms called ahu, while others lie toppled and broken, as if frozen in a moment of ancient catastrophe. The scene is haunting, but the most baffling aspect is not the statues themselves, but their journey. Nearly all of these giants were carved from a single quarry in the volcanic crater of Ronoroku. Yet they were transported somehow for miles across the island's rugged terrain to their final coastal perches. The largest of them, named El Gigant, still lies unfinished in the quarry. It is a staggering 70 feet long and estimated to weigh over 80 tons. How did a population that never numbered more than a few thousand people, completely isolated from the rest of the world and possessing only Stone Age technology, move mountains of rock across their island? This is not just a question of logistics, it is a profound puzzle about the human spirit under extreme constraints. For decades, the dominant theory, fueled by local oral tradition, was that the Moai walked. Not on their own, of course, but with a lot of help. This captivating idea was famously tested by archaeologists Terry Hunt and Carl Lipo, along with a team that included descendants of the Rapa Nui people. Their experiment demonstrated that it was indeed possible. Using 3 strong ropes tied around a concrete replica of a Moai, teams could walk the statue upright. One team would pull on a rope attached to the top, rocking the statue forward, while another team on the opposite side would steady it and guide its descent. With a rhythmic, coordinated rocking motion, the Moai could be inched forward in a swaying gait. The key was the statue's distinctive design, a large, bulbous belly that shifted its center of gravity forward, and a curved base that made the rocking motion more natural. This method required relatively small teams, perhaps 15 to 20 people, and a lot of skill and chanting to maintain the crucial rhythm. It was an elegant solution that seemed to align perfectly with the islanders' own legends of the statues walking with divine power or mana. However, a more recent and equally compelling theory has emerged, one that suggests a very different and perhaps more stable mode of transport. This is the parbuckling method. Instead of moving the Moai upright, this theory proposes they were laid flat on their backs on a log sledge. To move them, the islanders would have used a technique familiar to sailors for centuries, parbuckling. A long, strong rope would be looped underneath the sledge, with the two ends brought up and over the top. Teams of pullers would then haul on the ropes, using the principle of leverage to roll the sledge and its precious cargo forward over a path of lubricated logs. This method would have been significantly safer, reducing the risk of the statue tipping over and shattering on the rocky ground. It also explains the lack of widespread wear and tear on the statue's bases that one might expect from being walked for miles. Proponents of this theory point to the fact that many moai found along the ancient roads do, in fact, lie face down, as if they were in transit when abandoned. So, which theory is correct? The most likely answer is that both have merit, and the true story involves a combination of techniques, refined and adapted over centuries. The Rapa Nui people were brilliant engineers, not slaves to a single method. For shorter distances or over flatter terrain, walking a smaller moai might have been efficient and spiritually significant. For moving the absolute giants or across more challenging landscapes, the controlled stability of the parbuckling and sledge method would have been far less risky. Both methods, however, relied on the same underlying technologies, incredibly sophisticated rope making and immense social coordination. The ropes themselves were feats of engineering, woven from the tough fibers of the hau tree, capable of withstanding the enormous strain of controlling a multi-ton stone statue. The coordination required speaks to a highly organized society where teams worked in unison, likely directed by master navigators and engineers who understood the physics of moving massive objects. The story of the moai transport is more than an engineering puzzle. It is a powerful case study in human ingenuity in the face of extreme isolation. Easter Island is one of the most remote inhabited islands in the world, a tiny oasis of resources in a vast ocean. Every material, every tool, every ounce of food had to come from the island itself. There were no outside resources to call upon, no trade networks to supply exotic woods or stronger ropes. The Rapa Nui people had to make do with what they had, and their success in moving these monuments is a testament to their deep knowledge of their environment and their ability to innovate with limited means. The drive to create these statues was so powerful that it overcame every physical constraint. It was an expression of identity, a connection to ancestors, and a demonstration of clan power that was deemed worth any amount of effort. The silent moai scattered across the landscape are not just stone figures. They are the ultimate symbol of an unstoppable human drive to create, to honor, and to leave a mark on the world, proving that no island is too remote and no challenge too great for the power of a collective human will. Beyond the silent testimony of stone and the sheer force of coordinated labor, there exists a more ethereal dimension to these ancient sites, a dimension not of sight or touch, but of sound. We have explored the physical tools and the social engines, but what about the acoustic environment these builders may have intentionally created? Step inside the Hal Saflieni Hypogeum on Malta, an underground labyrinth carved from solid limestone over 5,000 years ago. In one particular chamber, known as the Oracle Room, something remarkable happens. A deep male voice spoken into a specific niche creates a powerful, resonant echo that seems to vibrate through the very stone, filling the entire space with a low, haunting hum that can be felt in your bones. This is not a random acoustic fluke. The chamber's shape and the properties of the limestone were almost certainly understood and manipulated by its creators. Similarly, in certain Inca structures, narrow corridors and precisely angled walls can amplify whispers, carrying them clearly over surprising distances. These are not mere curiosities. They are clues that sound was not just a byproduct of these spaces, but an integral part of their design and purpose. This leads to a captivating, though highly speculative, question. Could sound itself have been a construction tool? Some alternative theorists have proposed that the ancients discovered a lost acoustic technology, using specific resonant frequencies to counteract gravity or soften stone, making massive blocks easier to move. The idea of acoustic levitation is a staple of legend, from tales of Tibetan monks moving stones with trumpets to the biblical story of Joshua bringing down the walls of Jericho with a blast of horns. While there is no solid archaeological evidence to support such claims, and the physics involved is far beyond what we can reasonably attribute to these cultures, the persistence of these stories speaks to a deep-seated human intuition about the power of sound. It is a tantalizing thought, but one that belongs more to the realm of myth than to historical fact. A more scientifically grounded, yet still profound, possibility is that sound was used in the quarrying process. The act of sounding a stone, tapping it with a hammerstone, and listening to the pitch and timbre could have been a sophisticated diagnostic tool. A clear, ringing tone might indicate a solid, flawless block ideal for carving, while a dull thud could reveal hidden internal cracks or fissures, warning the masons away from a potentially flawed piece of rock. In this sense, sound was a form of ancient sonar, allowing them to see inside the stone with their ears. Setting aside these more speculative ideas, we find a much more concrete and powerful application of sound that is almost certainly true: its role in coordinating human labor. Imagine the scene at a quarry or a pyramid construction site. Hundreds, perhaps thousands of workers are engaged in a task that requires immense synchronization. Moving a multi-ton block on a sledge with ropes is not an activity that can be done in a chaotic free-for-all. It requires a unified, rhythmic pulse. This is where sound becomes an essential management tool. A lead foreman or a designated caller might have used a drum, a horn, or simply the power of his own voice to set a cadence. A strong, rhythmic chant, a deep, guttural heave, ho, would have served multiple critical functions. First, it provided a clear auditory signal for everyone to pull at the exact same moment, maximizing the collective force applied to the ropes. This synchronization turns a disorganized crowd into a single, powerful machine, but the benefits go far beyond mere coordination. Rhythmic sound has a profound psychological and physiological effect. The steady, repetitive beat of a drum or a chant can induce a trance-like state, distancing the mind from the agony of muscle strain and the monotony of the task. It can transform grueling labor from a torturous ordeal into a shared, almost meditative ritual. The sound would have helped to regulate breathing, allowing workers to maintain their effort for longer periods. It fostered a powerful sense of unity and shared purpose, turning individual exertion into a collective ceremony. The very act of creating sound together, of voices joining in a common rhythm, strengthens social bonds and builds morale. In this light, the construction site was not just a physical space. It was a sonic environment where the rhythms of work became the heartbeat of the project, driving it forward day after day, year after year. This holistic integration of sound completes our sensory picture of these ancient building sites. It was not a silent world of grim, silent toil. It was a vibrant, multi-sensory experience. The air would have been filled with the rhythmic percussion of hammerstones, the deep, resonant chanting of work crews, the creak of ropes and wooden sledges, and the shouted directions of overseers. This sonic landscape was as much a part of the construction process as the levers and the stones themselves. It engaged the workers' bodies, minds, and spirits, turning an immense engineering challenge into a coordinated performance. By considering the role of acoustics, we add a crucial layer of understanding. recognizing that these civilizations approached building not just as a technical problem to be solved, but as a holistic human endeavor that engaged every facet of their being, weaving together physical effort, social organization, and sensory experience into a seamless whole. When faced with the silent, staggering scale of a pyramid or the impossible precision of a polygonal wall, it is a very human reaction to search for an extraordinary explanation. The mind struggles to reconcile these monuments with the image of people using simple stone tools, and so a compelling narrative emerges that these wonders were built with the help of a lost, advanced technology or even by visitors from another world. The theory of ancient astronauts, popularized in the 20th century, suggests that extraterrestrial beings provided the knowledge or even the direct assistance needed for these constructions. Similarly, the enduring legend of Atlantis points to a sophisticated civilization that was wiped from the historical record, a master race whose advanced techniques were lost in a great cataclysm. These ideas tap into a deep sense of wonder and a desire for there to be more to our history than what is written in the textbooks. They offer a seemingly simple solution to a profoundly complex puzzle. It is crucial, however, to examine why these theories arise. Often, they are rooted in a subtle but pervasive form of condescension toward ancient peoples. The underlying assumption is that our ancestors were simply not capable of such feats on their own, that they were too primitive, too unsophisticated. The word primitive itself carries a heavy burden, implying a lack of intelligence, creativity, and organizational skill. This perspective fails to recognize that while their technology was different from ours, their intellect was not. They possessed the same cognitive abilities, the same capacity for observation, experimentation, and innovation that we do today. To attribute their achievements to aliens or a super civilization is, in a way, to rob them of their rightful legacy. It dismisses the generations of accumulated knowledge, the incredible social cooperation, and the sheer force of human will that these projects represent. It is a shortcut that avoids the more challenging but far more rewarding task of understanding their world on its own terms. Now, let's contrast these speculations with the weight of archaeological evidence. For every mystery, there is a growing body of research that provides grounded, human-scale answers. The unfinished obelisk in Aswan is not a mystery. It is a textbook, its surface etched with the clear tool marks of dolerite pounders. Experimental archaeology has repeatedly demonstrated that the techniques we propose using levers, ramps, rollers, and abrasive sand are not only possible but effective. We have seen teams of volunteers successfully walk a replica Moai, quarry stone using fire and water, and shape granite with nothing but harder rocks and patience. These are not just theories, they are methods that have been tested and proven to work with the materials available at the time. There is no need to invoke a mysterious, unproven technology when the tools and the principles are lying right there in the archaeological record. Furthermore, the idea of a single, lost source of knowledge like Atlantis fails to account for the incredible diversity of ancient engineering. The techniques used to build the pyramids of Egypt are distinct from those used for the walls of Sacsayhuamán, which are different again from the marine engineering of Nan Madol. These are not the products of a uniform, global instruction manual. They are brilliant, localized adaptations to specific environments, materials, and cultural needs. The Inca developed polygonal masonry as a direct response to earthquakes. The Egyptians mastered the art of moving massive stones across the desert sands. The builders of Stonehenge aligned their circle to the specific celestial events visible from their latitude. This diversity is a powerful argument for independent, incremental innovation. Each civilization solved its own architectural puzzles based on its own unique circumstances, drawing on centuries of trial and error, not on a shared secret inherited from a mythical predecessor. Ultimately, the real story of the vanished architects is a celebration of human potential. It is a narrative of patience where projects spanned generations, and the final product was a gift to descendants who would never meet the founders. It is a story of collective effort where thousands of people found meaning and identity in working toward a common, awe-inspiring goal. It is a testament to the power of the human mind to observe the natural world, the leverage of a log, the leveling property of water, the path of the sun, and to harness those principles on a monumental scale. This truth does not diminish the wonder of these sites, it amplifies it. To know that people no different from you and me, armed with little more than ingenuity and determination, could alter the landscape for millennia is a far more inspiring and humbling thought than any fantasy of alien intervention. The stones stand not as evidence of a lost external power, but as a permanent monument to the boundless capability of humanity itself. So, what does a civilization that built with stone hammers and log rollers have to teach our world of carbon fiber composites and robotic fabrication? The answer, it turns out, is almost everything. The legacy of these vanished architects is not locked away in a museum. It is a living, breathing source of inspiration for the most forward-thinking engineers and designers of our time. In an era defined by climate crisis and resource depletion, their principles are being rediscovered as blueprints for a more resilient and sustainable future. The first and perhaps most profound lesson is one of radical sustainability. These ancient builders were masters of what we now call the circular economy, though they would have had no name for it. They sourced their materials hyper-locally. The stones for the pyramids came from the Giza Plateau itself. The basalt for Nan Madol was quarried just across the water. The sarcens for Stonehenge were dragged from the nearby downs. This drastically reduced the energy cost of transportation. There were no diesel trucks hauling materials across continents. They used what the land provided, and in doing so, their structures harmonized with the local geology and climate, creating a seamless integration with the environment that is the very definition of sustainable design today. This philosophy of working with nature rather than against it is leading to a revolutionary reappraisal of ancient seismic engineering. For decades, modern construction in earthquake zones has relied on increasingly complex and expensive technologies, base isolators made of layers of rubber and steel, hydraulic dampers that act like shock absorbers for entire buildings. These are brilliant solutions, but they are also high-tech, high-cost, and require specialized maintenance. Then, engineers took a closer look at the Inca walls at Sacsayhuamán. Here was a structure that had survived hundreds of major quakes over 5 centuries using nothing but clever geometry and a deep understanding of material behavior. The irregular, interlocking blocks create a structure that is flexible, not rigid. When the ground shakes, the stones shift and settle, dissipating energy through friction. This has inspired a new field of research into low-tech, passive seismic design. Engineers are now experimenting with modern materials to recreate this polygonal, mortar-less principle, designing buildings that can dance with an earthquake just as the Inca walls do, but using pre-cast concrete blocks shaped with digital precision. It's a perfect fusion of ancient wisdom and modern material science, proving that sometimes the most advanced solution is also the most elegantly simple. The ancient mastery of celestial alignment is also finding new life in the world of green architecture. The builders of the Great Pyramid didn't need an energy bill, they had the sun. Their precise orientation was for spiritual reasons, but the effect was a form of passive solar design. Today, architects are using sophisticated software to model the sun's path over a building site, just as those ancient astronomers did with their gnomons and merkits. The goal is to maximize natural light and heat gain in the winter, while using strategic shading to keep buildings cool in the summer. This dramatically reduces the need for artificial lighting and air conditioning, which account for a massive portion of a building's energy consumption. The very concept of building orientation, which was a sacred science to the ancients, is now a fundamental pillar of LEED certification and sustainable building codes worldwide. We are, in effect, relearning how to build with the sun, not just under it, recognizing that the most abundant and cleanest source of energy has been lighting our way all along. Perhaps the most humbling lesson, however, is one of time. We live in a culture of disposability and planned obsolescence, where buildings are often designed with a lifespan of 50 or 60 years. We prioritize speed and cost efficiency over longevity. The monuments of the past stand in silent judgment of this short-term thinking. They were built with a multi-generational perspective. The people who laid the first stone for Stonehenge knew they would never see it completed. Their investment was not in their own lifetime, but in the legacy of their culture for centuries to come. This long-term perspective is something modern project management is desperately trying to recapture, especially when it comes to critical infrastructure like bridges, tunnels, and seawalls. The question is shifting from what is the cheapest way to build this to what is the most durable, resilient way to build this for our grandchildren. This requires a shift in values, a return to the kind of patience and quality over quantity ethos that allowed these ancient structures to become eternal. Ultimately, the greatest takeaway may be about the power of community-centric projects. We've seen how these monumental endeavors were not built by slaves under the lash, but by communities united by a shared purpose. The process of building was as important as the final product, forging social bonds and a collective identity. In our modern, often alienated world, there is a growing movement towards participatory design and community-built projects. Imagine a new public park where the community comes together to help with the planting and construction, not just to cut costs, but to create a shared sense of ownership and connection to the place. This echoes the communal effort that built the great earthen mounds of North America or the coral reefs of Nan Madol. The project becomes more than a piece of infrastructure. It becomes a ritual of community building, creating social capital that is as valuable as the physical structure itself. The ancient architects teach us that the most enduring monuments are not just made of stone. They are built from the shared purpose and collective spirit of the people who raised them. In looking back to their methods, we are not just finding better ways to build. We are rediscovering a more meaningful way to build together. Of all the mysteries surrounding these ancient marvels, perhaps the most persistent one isn't about how they were built, but who built them. And the answers we invent say as much about us as they do about the past. It's time to clear the air of speculation and confront the most popular myths head-on, replacing fantasy with the even more incredible facts. The most widespread of these is the idea that these structures were simply too advanced for their time, leading to the compelling but ultimately dismissive conclusion: they must have had help from aliens or a lost super-civilization like Atlantis. This theory is seductive because it offers a simple answer to a complex question. But when we look closely, we find that every single technique proposed, from using levers and ramps to move stones, to grinding granite with abrasive sand, has been successfully demonstrated by archaeologists and volunteers using only the tools and materials these cultures had access to. The real story isn't about a technology that was lost. It's about a scale of patience and social organization that we, in our fast-paced modern world, have simply forgotten. To attribute these wonders to extraterrestrials is to overlook the true marvel. the boundless potential of focused human ingenuity. Another common misconception involves staring at the seamless joints of an Inca wall and concluding that such perfection is impossible with stone tools. The myth suggests that the ancients must have discovered a way to soften or even melt the stone, pouring it into place like concrete. While it's a fantastic image, the reality is both more mundane and far more impressive. That mirror-like finish and impossibly tight fit was achieved through a process of relentless, painstaking abrasion. Stonemasons would use a simple mixture of quartz sand and water as a grinding paste, rubbing one stone against another for days, weeks, or even months. They might use a saw, a simple strip of leather or copper pulled back and forth with sand in the cut to slowly, incrementally slice through the rock. This wasn't a secret chemical process, it was the application of sheer, unwavering persistence. The precision comes from a deep, tactile knowledge of the material, where craftsmen learned to read the stone, shaping it through countless small adjustments until it locked perfectly with its neighbor. The result is a testament not to a mysterious softening agent, but to the incredible power of human diligence. Then there is the enduring image, popularized by Hollywood, of these projects being built by millions of groaning slaves under the crack of a whip. This picture of brutal oppression is powerfully evocative, but the archaeological evidence paints a very different and more nuanced portrait. Excavations of the workers' villages at Giza, for instance, reveal not a slave camp but a functioning town with bakeries, breweries, and medical facilities where skeletons show signs of healed fractures, proof that injured workers were cared for, not discarded. These were often skilled laborers organized into crews with proud names like the Friends of Khufu. In many societies, this work was a form of civic or religious duty, known as corvée labor, or in the Inca Empire, mita. It was a rotational service that citizens owed to the state, often taking place during the off-season from farming. In return, the state provided food, shelter, and a sense of participation in a grand, collective project that reinforced cultural identity and divine order. This was not the chattel slavery of more recent times. It was a complex social contract that bound the community together in a shared, monumental endeavor. By systematically dismantling these myths, we do more than just correct the historical record. We empower ourselves with a more respectful and accurate understanding of these ancient cultures. The fantasy of alien architects or melted stone, while entertaining, ultimately diminishes the achievement. It suggests that our ancestors were incapable of such greatness on their own terms. The truth that ordinary people, using extraordinary patience, clever physics, and unparalleled social cooperation, created these wonders, is a far more inspiring narrative. It challenges our modern arrogance and redefines what we consider to be advanced. Their technology wasn't in complex machinery, but in a profound wisdom applied over generations. When we let go of the need for a magical explanation, we can finally see these monuments for what they truly are, not gifts from the stars, but the crystallized ambition and collective spirit of humanity itself. A legacy written in stone that continues to challenge and inspire us thousands of years later. If you were to choose the perfect foundation for a structure meant to last for millennia, you would be hard-pressed to find a better one than the Giza Plateau. The Great Pyramids do not simply sit upon the desert, they are an extension of it. This vast limestone bedrock is not just stable, it's a fundamental part of the architectural plan. The builders understood that the stone they quarried for the core blocks was the very same stone upon which they were building. This was a closed-loop system of incredible efficiency. But their geological insight went even deeper. They intentionally positioned the pyramids on a natural limestone spur, a slight elevation that provided a perfectly level and incredibly strong base, naturally resistant to the shifting sands and potential groundwater that could undermine a less thoughtfully placed structure. This wasn't a random choice, it was a masterstroke of environmental engineering, ensuring that the immense weight of the monuments would be distributed across the most resilient part of the landscape. They weren't fighting the desert, they were using its own inherent strength as their primary building material. This philosophy of collaboration with the environment reaches its zenith high in the Andes at Machu Picchu. The Inca didn't just build on a mountain, they built with the mountain. Walk through the citadel and you will see that its most stunning feature is the way man-made stone flows seamlessly into the natural rock outcrops. Entire buildings are constructed around existing granite boulders with walls curving to embrace them. In the Temple of the Sun, a massive, sculpted stone altar is integrated with a natural rock formation, creating a sacred space that feels both crafted by hand and born from the earth itself. This was more than an aesthetic choice, it was a profound structural decision. By tying their architecture directly into the living bedrock, they anchored it against the violent earthquakes that frequently shake the region. The building and the mountain became a single, unified entity, moving together during seismic events rather than the rigid man-made structure shattering against the immutable power of nature. Perhaps the most sophisticated aspect of this integration is what you don't see immediately: the water management. Machu Picchu is a marvel of hydraulic engineering, built on a steep, rain-drenched mountainside. Instead of fighting the water, the Inca designed a system to welcome it, channel it, and let it flow through the city without causing erosion. A complex network of stone-lined canals runs underneath the pathways, fed by a natural spring on the north side of the ridge. These channels directed fresh water to a series of fountains, providing for the residents, while a carefully calculated gradient and extensive drainage systems ensured that torrential rain was swiftly carried away from the foundations of the buildings. They carved drainage spouts directly into the stone, and the central plazas were even built on layered foundations of stone and gravel that acted as natural sponges and drainage beds. They understood the watershed of their mountain so intimately that they could predict the flow of water and design a city that would remain dry and stable for centuries, a feat that modern engineers still admire. This deep ecological knowledge extended to every aspect of their site selection. These ancient architects were master readers of the land. They chose locations based on a trifecta of practical, strategic, and spiritual considerations that were often one and the same. A site had to be geologically stable, like the Giza Plateau, to support the immense weight of their constructions. It needed strategic visibility, perched on a hilltop or a cliff face for defense, and to project power across a valley. But these practical reasons were deeply intertwined with a spiritual understanding of the world. A mountain was not just a defensible position, it was an apu, a sacred mountain spirit. A spring was not just a water source, it was a gift from the earth goddess Pachamama. By building in harmony with these powerful natural features, they were not just constructing a building, they were honoring the deities they believed resided within the landscape. The alignment of a temple with a specific mountain peak or a solstice sunrise was both a practical celestial marker and a sacred act of connecting the human realm with the cosmic and the divine. This holistic approach stands in stark contrast to much of modern development, where the first step is often to bulldoze the land flat, to force the environment to conform to the blueprint. The ancient way was the opposite. The blueprint was derived from the environment itself. They looked at a cliff face and saw a natural defensive wall. They felt the prevailing winds and oriented buildings to capture breezes for natural ventilation. They studied the path of the sun across the seasons to position windows and doors for optimal light and heat. Their constructions were not imposed upon the landscape, they were conversations with it. This respectful dialogue is the primary reason these places have survived thousands of years of hurricanes, earthquakes, and erosion. They weren't just built to be strong, they were built to be resilient, to adapt and endure as part of the living ecosystem. In an age of climate change and environmental crisis, this lesson in building with the land, not against it, is perhaps the most valuable legacy these vanished architects have left for us. It is a reminder that true sustainability isn't about adding green technology to an unsustainable design, but about designing from the start in harmony with the forces that have shaped our world since the beginning. But after we have marveled at the levers and counted the work crews, after we have mapped the celestial alignments and analyzed the stonework, we are still left with the most profound question of all: why? Why would a society, any society, commit generations of toil and a vast portion of its collective wealth to a project that offered no immediate shelter, no food, no direct practical return? The answer lies not in the realm of engineering, but in the deep, complex currents of human psychology. Across continents and millennia, these civilizations were all answering a fundamental, driving impulse to reach beyond the ordinary, to create something so grand it would defy the very passage of time. One powerful force at work is what we might call conspicuous construction. In a world without global media or instant communication, the most potent way for a ruler or a ruling class to project power was to alter the landscape itself. A pyramid rising against the horizon is not just a tomb, it is a permanent, undeniable advertisement of a pharaoh's absolute authority. It declares, in a language that every subject can understand, that the ruler commands the labor of thousands, the resources of a nation, and the favor of the gods. For the Sordilor dynasty at Nan Madol, building a city on a coral reef was an act of breathtaking audacity. It physically separated the elite from the common people, creating a visible, almost magical demonstration of their superior status and control over both land and sea. This kind of monumental building is the ultimate statement of dominance, a way of making power tangible and eternal, ensuring that a king's name would be remembered long after his deeds were forgotten. Yet the desire for legacy runs even deeper than the thirst for political power. It taps into a universal human anxiety, the fear of being forgotten. We are mortal beings in a vast, seemingly eternal world, and the drive to leave a mark is a powerful antidote to our own transience. To erect a structure that will stand for thousands of years is to send a message in a bottle to the future. It is a way of saying, we were here, we existed, we mattered. The anonymous builders of Stonehenge may not have sought individual fame, but as a community, they were driven to create a permanent symbol of their presence, their beliefs, and their understanding of the world. Each stone they raised was a defiant act against oblivion, a desperate and beautiful attempt to secure a place in the memory of generations yet unborn. The monument becomes a bridge across time, connecting the living with the ancestors and reaching out to descendants in a silent, enduring conversation. This yearning for permanence was often channeled through a profound religious or spiritual imperative. For many ancient cultures, the cosmos was a fragile, orderly system that required constant maintenance. The pharaoh's journey to the afterlife was not a private affair. It was a matter of state security, essential for ensuring the sun would continue to rise and the Nile would flood its banks. Building his pyramid was therefore a sacred duty, a collaborative ritual performed by the entire society to uphold cosmic order. At Göbekli Tepe, the very act of gathering, quarrying, and carving may have been the central religious practice. The construction site was the temple, and the labor itself was the worship. By coming together to create something monumental for their gods or ancestors, they were actively participating in the spiritual life of the community, reinforcing a shared worldview that gave meaning to their existence. The stones were a physical anchor for their beliefs, a permanent home for the divine in a mutable world, and it is within this communal effort that we find perhaps the most vital psychological driver. The process of building was itself a powerful social ritual. Imagine the scene: thousands of people from different villages working in coordinated teams, sharing the strain of the ropes, the rhythm of the chants. This shared, arduous endeavor forged powerful bonds of camaraderie and collective identity. It transformed a diverse population into a single people with a common purpose. The pyramid, or the stone circle, was the magnificent byproduct of this process, but the true creation was the strengthened social fabric itself. The project gave people a role, a sense of belonging to something greater than their individual lives. In an age before nations, these monumental constructions were the crucibles where culture was forged, where stories were shared, skills were taught, and a shared history was literally built stone by stone. The monument was the destination, but the journey of building it was what truly held the civilization together, turning abstract cultural values into a tangible, collective achievement that everyone could see and touch for centuries to come. The connection between ancient architecture and the heavens extends far beyond simply aligning a doorway with a rising star. For many cultures, the entire landscape became a sacred canvas, a place where the cosmic order was not just observed but actively inscribed into the very earth. This practice, known as landscape astronomy, represents a profound fusion of sky, land, and spirit. It suggests that the choice of where to build was as spiritually significant as how to build, and that the layout of their greatest sites was a deliberate act of creating a mirror of the heavens on earth. The most stunning example of this intimate celestial connection is found not in a towering pyramid, but within a grassy mound in the Boyne Valley of Ireland. Newgrange is a massive, circular passage tomb, older than both Stonehenge and the Great Pyramid. From the outside, it appears as a large man-made hill, but its true magic is hidden within. A long, narrow passageway leads to a central chamber deep inside the mound. Above the entrance, a small, carefully engineered opening known as a roof box seems like a minor architectural detail. But for a few precious minutes at dawn on the winter solstice, around December 21st each year, this small window transforms the entire structure. As the sun crests the horizon, a single, sharp beam of sunlight pierces the darkness, traveling directly up the passageway to illuminate the inner chamber for approximately 17 minutes. This event is not a happy accident. It is the entire purpose of the tomb's precise orientation. In the depths of the darkest time of the year, this dramatic infusion of light into a place of death symbolized rebirth, the promise of the sun's return, and the eternal cycle of life. The builders of Newgrange did not just build a tomb aligned to the sun. They built a mechanism for a spiritual experience, using the landscape itself to capture a moment of cosmic power. This practice of weaving astronomy into the geography takes an even more expansive form on the arid plains of Peru, with the world-famous Nazca lines. These are not structures you can walk through, but immense geoglyphs, enormous designs etched into the desert floor by removing the dark surface stones to reveal the lighter earth beneath. From ground level, they are largely incomprehensible, appearing as little more than shallow grooves. But from the air, the true scale and complexity are revealed. Vast depictions of spiders, monkeys, hummingbirds, and intricate geometric shapes stretching for miles. For a long time, their purpose was a complete mystery. How could a people create such precise, massive artwork that they themselves could never fully see? While many theories exist, a compelling idea is that the Nazca lines are a supreme example of landscape astronomy created for a divine audience. Researchers have found that many of the long, straight lines align with the rising and setting points of the sun, moon, and significant stars during solstices and other key dates in the agricultural calendar. Furthermore, the lines often lead to sources of water, the most precious resource in the desert. This suggests the geoglyphs were part of a vast ritual landscape, a kind of outdoor temple used for ceremonies related to water, fertility, and celestial cycles. The figures themselves may have represented constellations or mythological beings. By walking these lines or performing rituals along them, the Nazca people were not just looking at the sky. They were walking a path mapped out by the gods, physically tracing the connection between the celestial patterns that governed their world and the life-giving water that sustained it. Their homeland became a cosmic diagram, a prayer for survival written on a scale so grand it could only be read by the deities in the sky. This concept of sacred geography is a thread that connects cultures across the globe. In ancient Mesopotamia, the great ziggurats were not just temples. They were artificial mountains, constructed to serve as stairways between heaven and earth for the priests to commune with the gods. In Cambodia, the Temple of Angkor Wat is designed as a microcosm of the Hindu universe, with its central towers representing the mythical Mount Meru, the axis of the world. The entire layout is precisely aligned with the sun, and during the equinoxes, the sun rises directly over the central tower, again linking the earthly structure with the celestial order. Even the layout of ancient Chinese capital cities was based on strict cosmological principles, with streets and walls aligned to the cardinal directions to reflect the harmony of the cosmos. This universal impulse shows that for these civilizations, astronomy was not a separate science but an integral part of their worldview. They saw the universe as an interconnected whole, where the movements of the stars directly influenced the fate of individuals, the success of harvests, and the stability of kingdoms. To build a city, a temple, or a tomb was to participate in this cosmic order. By aligning their constructions with the heavens, they were anchoring their community within the divine framework, ensuring that their world was in harmony with the greater universe. Their architecture was an act of cosmic diplomacy, a way of saying to the gods, "We see your order, we honor it, and we have built our home within its sacred patterns." This deep, symbolic relationship between earth and sky is what elevates these sites from mere buildings to profound philosophical statements, turning the entire landscape into a page from a celestial scripture. But how can we be so confident that these proposed methods actually worked? After all, theories about levers and ramps sound convincing on paper, but the true test comes when you try to put them into practice with the same basic tools. This is where the fascinating field of experimental archaeology comes into play, turning academic speculation into tangible, hands-on reality. Instead of just studying artifacts in a museum, experimental archaeologists roll up their sleeves and attempt to recreate ancient processes from start to finish. Their workshops are not sterile laboratories but dusty quarries and open fields, and their goal is simple yet profound: to see if it can be done. These projects are the ultimate reality check, separating plausible ideas from impractical fantasies, and in the process, giving us a visceral, unforgettable appreciation for the skills of the original builders. One of the most ambitious and publicized experiments was led by archaeologist Mark Lehner in association with the Nova television series. Their mission was audacious: to construct a small-scale pyramid about 20 feet high, using only the tools and techniques available to the ancient Egyptians. The project began at the most fundamental stage, quarrying a limestone block. Teams of volunteers used rounded dolerite hammerstones, swinging them rhythmically to pound a channel around the desired block. The process was brutally slow and physically exhausting, the air filled with the relentless, percussive tapping of stone on stone. It took an immense amount of time and effort just to free a single block from the bedrock, a humbling lesson in the sheer patience required. But it worked. The method of pounding and then using wooden wedges soaked with water to create expansion fractures proved entirely effective, leaving behind tool marks identical to those found in ancient quarries. The next challenge was transportation. The team fashioned a large wooden sledge and placed their multi-ton block on top. Then, on a path prepared with log rollers, a group of about 20 people pulled on heavy ropes. At first, the sledge refused to budge, a stark reminder of the immense friction they were fighting. But then, by pouring water onto the path in front of the rollers, they created a slick layer of mud that dramatically reduced the resistance. Suddenly, with a coordinated heave, the sledge began to move. The effect was transformative. What had seemed an impossible task became a manageable, albeit still grueling, effort. This simple act of lubrication was a revelation, demonstrating a practical trick that would have made moving hundreds of thousands of blocks feasible. Finally, they used earthen ramps and levers to lift the blocks into position, completing their miniature pyramid. The experiment was a resounding success, not because it was easy, but because it proved that with the right knowledge, teamwork, and persistence, the methods were entirely viable. The real discovery was the immense gap between theoretical possibility and the gritty, physical reality of the work. While some experiments test physical techniques, others investigate the intellectual achievements of these cultures, such as their celestial alignments. Archaeoastronomer J. McKim Malville spent years studying Inca sites like Machu Picchu, carefully mapping the positions of windows, doors, and carved stone pillars against the horizon. He proposed that certain structures were designed as precise solar observatories. To test this, he and his team would be present at these sites during solstices and equinoxes. Their work wasn't about moving stone, but about observing light. At the crucial moment of sunrise on the winter solstice, they witnessed the sun's rays pierce through a specific window in the Temple of the Sun and strike a carefully placed ceremonial stone inside. This was not a vague alignment. It was a precise, repeatable event that confirmed the Incas' sophisticated understanding of the solar cycle. This kind of experimental validation moves beyond guesswork, providing concrete evidence that these structures functioned as astronomical instruments, their architects possessing a knowledge of the heavens that was both profound and practical. These hands-on projects are crucial because they consistently reveal unexpected complexities that pure theorizing misses. An idea might look perfect in a diagram, but when you try it with real materials, new challenges emerge. For instance, experiments in moving Moai statues on Easter Island showed that walking a statue was possible, but it required an exquisite sense of rhythm and coordination to prevent it from tipping over. This discovery highlights the importance of skilled leadership and vocal coordination among the workers, a social technology that is invisible in the archaeological record. Similarly, experiments in shaping granite with dolerite hammers revealed that the stoneworkers likely had an intimate knowledge of the rock's grain, knowing exactly where and how to strike for maximum effect. This tactile, sensory knowledge can only be gained through direct experience, reminding us that the ancient masters possessed a deep, hands-on wisdom that we are only beginning to comprehend. Ultimately, experimental archaeology does more than just prove a point. It builds a bridge of empathy across thousands of years. By physically struggling with a heavy sledge or spending a cold night waiting for a solstice sunrise, researchers gain a profound respect for the original builders that no textbook can provide. They feel the strain in their muscles, the frustration of a failed attempt, and the triumph of a successful one. This is science in its most human form, a discipline of doing and feeling that validates the genius of the past not through complex equations, but through shared effort. It transforms our view of these ancient people from mysterious, almost mythical figures into practical, brilliant engineers and astronomers whose achievements were rooted in a deep, hard-won understanding of their world. Every successful experiment is a tribute to their skill, a quiet nod of recognition from the present to the past, confirming that the secrets of the vanished architects were not magic, but mastery. Imagine two master builders separated by an ocean and 1,000 years. One stands in the dense, ancient forests of northern Europe, surrounded by towering oaks and pines. The other works under the blazing sun of the Egyptian desert, where the horizon is an endless sea of sand, and the only trees are thin, hardy acacias along the distant Nile. Both are tasked with moving a massive stone block. Their goal is identical, but the solutions they devise will be worlds apart, dictated entirely by the resources their environment provides. This fundamental truth is the key to understanding the incredible diversity of ancient engineering. There was no universal secret, no one-size-fits-all technique. Instead, the genius of these civilizations was their ability to conduct a deep, creative dialogue with the world immediately around them, crafting a unique architectural language from the specific vocabulary of their local landscape. In the timber-rich regions of Europe, wood was the indispensable partner to stone. For the builders of Stonehenge or the great timber circles that preceded it, the forest was a living toolkit. The task of moving a 30-ton sarsen stone became a problem that wood could solve. They would fell giant trees to create robust sledges and fashion countless log rollers from smaller trunks. These rollers, placed in a continuous track ahead of the sledge, transformed sliding friction into the much more manageable rolling friction, but the innovation did not stop there. In some boggy areas, archaeologists have found evidence of what might be called timber highways, corduroy roads made of logs laid side by side across soft ground, creating a stable pathway that could support immense weights. The leverage principle, so vital for lifting, was also executed in wood, with long, sturdy poles serving as levers and smaller blocks as fulcrums. In these environments, construction was a symphony of carpentry, where the knowledge of joinery and wood grain was as important as the understanding of stone. Now cross the Mediterranean to ancient Egypt, and the available resources shift dramatically. Here, wood was a precious commodity, largely imported from distant Lebanon for royal projects. The desert offered a different abundance, stone and vast quantities of it. This scarcity of wood forced a completely different approach. While sledges were still used, the emphasis shifted to managing friction without the luxury of abundant rollers. This is where their famous use of lubricants came to the fore. They would pour water or a slick slurry of Nile mud onto the path ahead of a stone-laden sledge. This created a slick surface that reduced the grinding resistance, allowing large teams of pullers to drag the colossal blocks across the desert. Furthermore, the primary building material itself changed. While the pyramid's core is limestone, the Egyptians also became masters of mud brick, using the rich, fertile clay deposited by the annual Nile inundation to build everything from royal palaces to the homes of workers. Sun-dried and incredibly durable in the arid climate, these mud bricks were a perfect adaptation to the local conditions, creating cities that were cool, affordable, and made entirely from the earth beneath their feet. This intimate relationship with local geology is perhaps most vividly illustrated by comparing the stone-working techniques of different cultures. The choice of material directly dictated the method of construction. In Egypt, the widespread use of hard stones like granite and basalt necessitated a technology of percussion and abrasion. Shaping a granite block with a copper chisel was futile. Instead, workers used pounders made of even harder dolerite to literally pulverize the stone grain by grain. This was a slow, thunderous process that yielded incredibly durable results. Now, travel to the islands of Malta, where the prehistoric temples of Haga Kim and Mnajdra were built. Here, the builders worked with Globigerina limestone, a much softer, almost chalk-like stone. This material was a sculptor's dream. It could be cut and shaped with relative ease using stone and even wood tools, allowing for intricate spirals, animal reliefs, and finely dressed walls that would have been unimaginable for an Egyptian mason working with granite. The soft stone allowed for a more artistic, fluid style of architecture, proving that the very aesthetic of a civilization was shaped by the rock beneath its soil. This principle of environmental adaptation extends to the most remote corners of the ancient world. Consider the stark contrast between the seafaring culture of Nan Madol and the mountain empire of the Inca. On the tiny Pacific island of Pohnpei, timber was available, but the defining resource was the ocean itself and the unique prismatic basalt columns created by volcanic activity. Their entire architectural identity was formed by this material, leading to the unique log cabin style of construction that defined their aquatic city. Conversely, high in the Andes, the Inca had access to vast forests, but they also lived in a world defined by seismic violence. Their response was to develop a stone-based architecture that prioritized flexibility and strength over the use of wood, which would be vulnerable to earthquakes and decay. Their polygonal walls were a direct, brilliant response to the tectonic forces of their environment. Each civilization looked at the same fundamental challenges: how to move weight, how to create shelter, how to build for the ages, and found completely different answers written in the language of their local geography, climate, and available materials. Their genius was not in discovering a single secret, but in possessing the wisdom to ask the right questions of the world they inhabited, and then listening carefully to the answers it provided. Yet for all the brilliant detective work and experimental breakthroughs, the story of these vanished architects is far from complete. In fact, the deeper we dig and the more we learn, the more we realize how many profound questions remain tantalizingly unanswered. This is not a sign of failure in our search, but rather the most exciting part of the journey. The past is not a puzzle with a single solution waiting to be found. It is a living conversation, and every answer we uncover simply leads us to a dozen new, more fascinating mysteries. The legacy of these builders is a gift that keeps on giving, ensuring that the field of archaeology is as dynamic and forward-looking as any modern science. Consider the iconic lintels of Stonehenge. We have compelling theories about how the massive sarsen uprights were raised, but the process of lifting the equally heavy lintel stones to perch perfectly atop them is a puzzle that continues to spark lively debate. The most common hypothesis involves the construction of a massive wooden ramp made of earth and timber, built up against the two standing stones. The lintel would then be dragged up this incline, a Herculean effort requiring immense ramps and precise control. Once at the top, how was it maneuvered into its precise position? Some suggest the use of wooden cribbing, a stack of timber frames that could be built up underneath the stone, allowing it to be lifted in small increments with levers and then shifted horizontally. Others propose a more complex system of levers and counterweights. The truth is, without a time machine, we may never know the exact method, and this very uncertainty is a reminder of the sophisticated, on-the-fly problem-solving skills these ancient engineers possessed. Then there are the sites whose purpose remains utterly enigmatic, whispering secrets we have yet to decipher. On the coast of Brittany in France, for instance, stand the Karnak stones, over 3,000 prehistoric standing stones arranged in staggering parallel rows that stretch for miles. Walking among them is an eerie experience. Unlike Stonehenge, there is no clear circle, no obvious focal point. Were they a gigantic astronomical calendar, their alignments marking the movements of the sun and moon? Could they have been a sacred boundary separating the land of the living from the realm of the dead? Or were they territorial markers for different tribes? The sheer scale is overwhelming, suggesting a social organization of unbelievable complexity, yet their silent, sprawling arrangement offers no easy answers. They stand as a monumental question mark carved in granite, challenging us to understand a worldview that is completely lost to time. The tools of discovery, however, are advancing at an incredible pace, opening up new chapters of this ancient story that we never knew existed. One of the most revolutionary is LiDAR, which stands for light detection and ranging. This technology involves mounting a laser scanner on an airplane or drone and flying over a landscape, often one choked with dense jungle. The laser pulses can penetrate the thick forest canopy, bouncing off the ground below to create a highly detailed, three-dimensional map of the terrain. What appears to the naked eye as an impenetrable green wilderness is suddenly revealed by LiDAR to be a carefully engineered landscape. In recent years, this has led to breathtaking discoveries across Central America and Southeast Asia. Vast, previously unknown cities have been revealed in the Guatemalan jungle, complete with pyramids, palaces, and complex road systems, forcing us to completely rethink the scale and population of ancient Mayan civilization. Each new laser scan is like turning on a light in a dark room, showing us that what we thought was empty space is actually filled with the ghosts of entire cities, their stories waiting to be told. This ongoing research is a powerful antidote to the idea that history is a static, settled subject. It is quite the opposite. Every archaeological dig, every satellite image, and every new technological application is like adding a new piece to an infinite jigsaw puzzle. The picture becomes clearer in some areas, but the borders of the puzzle keep expanding, revealing vast new territories of ignorance and wonder. The questions we ask today are more nuanced than ever before. We are no longer just asking, how did they build it, but what was the experience of the people who built it? We use chemical analysis on pottery to trace ancient trade routes. We study the DNA of skeletons to understand migration patterns and genetic relationships. We analyze soil samples for ancient pollen to reconstruct the diets and agricultural practices of these societies. This is why the search for the vanished architects is so endlessly compelling. It is a journey without a final destination. The stones they left behind are not just silent monuments, they are active participants in a dialogue across millennia. They challenge our assumptions, ignite our curiosity, and humble us with the sheer scope of human achievement. The fact that we are still debating the methods at Stonehenge, still pondering the purpose of the Karnak alignments, and still discovering lost cities in the jungle is a testament to the enduring power of their legacy. The work of understanding them is never done, and that is the greatest tribute we can pay to their genius. The conversation between the past and the present continues, and each new discovery ensures that the voices of these master builders will never truly be silenced. So as we stand once more in the shadow of the Great Pyramid, the desert wind whispering across millennia, the structure before us is transformed. It is no longer a silent, enigmatic tomb, but a vibrant, echoing workshop of the human spirit. The vanished architects were not sorcerers wielding lost technologies, nor were they passive recipients of extraterrestrial wisdom. They were us. They were human beings of extraordinary intelligence, profound patience, and a collective spirit so powerful it could literally move mountains. Their greatest technology was not forged in fire, but cultivated in the mind and the community. It was a deep, accumulated knowledge of physics and geology, a breathtakingly sophisticated organization of labor, and a sacred, symbiotic connection to the natural world that modern society is only just beginning to relearn. This legacy stands as a quiet but firm challenge to our own age of technological arrogance. We often equate progress with the complexity of our gadgets, believing that more powerful tools are the sole path to greater achievement. The pyramids Nan Madol and Sacsayhuamán remind us that true greatness is not a product of the tool in your hand, but the vision in your mind and the will in your heart. It is achievable with nothing more than ingenuity, perseverance, and a shared sense of purpose. These monuments are a testament to what can be accomplished when a society aligns itself toward a goal that transcends individual lifetimes, when people are united by a common vision that is larger than themselves. They prove that the most durable materials are not steel and concrete, but knowledge, cooperation, and a reverence for the world we inhabit. The stones they left behind are far more than inert monuments to forgotten kings. They are messages carefully carved not in any language, but in the universal dialect of human ambition. They ask us a simple, haunting question: what is the measure of a civilization? Is it the fleeting convenience of our digital age, or is it the enduring mark we leave upon the earth and the legacy we bequeath to the future? They urge us to remember our own potential, to consider what we, as a global community, are capable of when we pool our intellect, our resources, and our collective will. The silent, patient endurance of these structures is a call to think not in terms of quarterly reports or election cycles, but in generations, in centuries. This brings us to a final, reflective question, one that we must each carry forward. The ancient builders poured their collective spirit into projects meant to speak to eternity. What story will our civilization tell? What grand projects, what enduring messages will we leave behind for future generations to discover and ponder? Will our legacy be one of sustainable harmony with the planet, of great works of art and engineering that uplift the human spirit? Or will it be a layer of plastic in the geological record, a cautionary tale of short-term thinking? The choice is ours to make, starting today. The lesson of the vanished architects is not about how they built, but why. And that is a question that now, more than ever, demands an answer from all of us. If this journey into the depths of history has sparked your curiosity, we would love to hear your thoughts in the comments below. What ancient mystery captivates you the most? And if you're ready for more explorations into the forgotten corners of our past, be sure to subscribe for our next adventure.